Okay, let's solve some word problems. So first off, solving word problems. Okay, my big point of doing this is always what are they asking for? What are they trying to get? What do they give us? So I'm just going to start off, just going to work through these again. Hopefully give you something to go back and watch. Hopefully it'll help you understand how to solve these a little bit, but just making sense of this. So we got Jeff and Max are college roommates. So Jeff can clean his apartment in 2.5 hours. So that's notable, right? So 2.5 hours, and he's cleaning one apartment. Okay, so that's notable. Key information. Max can clean their apartment in 3.5 hours. So we have 3.25 hours. He can clean one apartment. Okay. How long will it take Max and Jeff to clean their apartment together? So here's the thing. Those are rates. They are cleaning one apartment in 2.5 hours. That's a rate. And so in order to solve this, right, you have to understand distance equals rate times time. Now you're like, Coach, that's not a distance. Correct. But it's what we're doing, right? It's one apartment at a certain rate for a certain time, okay? So what do we have? We have time, right? And we have our rates, okay? So, but what are we trying to do together? We're trying to clean one apartment, the two of them together, right? So what are they trying to do? They're trying to clean one apartment, okay? Well, I have Jeff's rate, one apartment over 2.5 hours for a certain time, plus Max's rate, 1 over 3.25 for a certain time. Okay, so now what would I do? Well, in order to add this, I must have a common denominator. Okay, so what I would tell my pre-calculus students then is to use their calculator to do this. So they're going to multiply 3.25, or the giant 1. Okay, as our book describes it, we're going to multiply this side by 2.5 over 2.5. Okay, and so as we're doing that, okay, and as we get this common denominator, so how this is going to work here is we're going to have 3.25 t. I'm going to go ahead and put t together, right? And then I'm going to have that common denominator, right? So 2.5 times 3.25, right? And I get a common denominator of 8.125, okay? Plus, over here, again, common denominator, 8.125, and on top I'm going to have 2.5 t, again, cleaning one apartment. Okay, so I now can add, right? I can add since I have a common denominator. So when I add those together, I get 5.75 t over 8.125, okay? So now, in order to get t by itself, I'm going to multiply by the reciprocal. So I'm going to get t equals, right? And this 1 is going to basically, anything times 1 is itself. So I'm just going to go ahead and write the reciprocal here. And then I'm going to say, okay, 8.125 divided by 5.75, and I get a t of 1.41 hours. That is hours, right? That's what our rate is in. Okay, so now what I asked is, it doesn't necessarily say this, like that solves the problem, that's the solution. But I was like, what is this? What does 0.41 mean? Okay, and it's 0.41 of an hour. But hours are based on 60 minutes. So if I wanted the minutes, I would have 1 hour, and I would have 41.41, right, of an hour. So I take that and I multiply it by 60 minutes to get my minutes, okay? So if I did that, I get 1 hour and 24.6 minutes. Okay, so again, well, what's 0.6 of a minute? Okay, well, minutes are based on seconds, so that's 0.6 of 60 seconds. So I would have 1 hour, 24 minutes, And I would take 0.6 and multiply it by 60 seconds. And I get 36 seconds. So I can have it down to the second of exactly how long it took them to clean that apartment. Okay, moving on to the next problem. Okay, the sum of two positive integers is 9. So again, sum, so I'm adding two integers. So like x is, sorry, not integers, numbers. X and y, let's say that's x is the first, y is the second. We're going to sum them. So x plus y, that's the sum, is 9, right? Is always equals. And then we say, what is the maximum product, right? So product would be x times y. And it says the first number times the square of the second number. And we want to find the maximum. Okay? So that's key here. So the first thing we need to do is get to one variable, one equation, so we can solve this. Okay? And so how do we do that, right? Well, let's just solve for y. So y equals 9 minus x, right? And we're going to plug that in over here. So we have x times 9 minus x squared, and we want to find the max. So again, this is x. This would be 81 minus 18x plus x squared. Okay, and then we distribute the x, so we have 81x minus 18x squared plus x cubed. Now, this is a cubic function, okay? So we should know in pre-cal that our cubic functions will always look something like this, okay? Especially a positive cubic. Well, coach, we're trying to find the max, right? So we know there's a local maximum there within our range. So what we would need to do then is to graph this, and once we graph this, we can find a maximum. Okay, so what I would tell you is to go on your calculator, graph it, and find the maximum. Okay, so I can't do this on here. I can't show you this with the screen going on. Actually, I might be able to, guys. Hold on, give me a second. Let's see if I can get Desmos here, and we'll graph it that way. Yeah, maybe. Yeah, come on. So let's do this. So let's go 81x minus 18x squared plus x. Let's see if we can. Nope, I don't want squared. Gonna have to go to functions. And see if I can find. Oh, sorry, had it. I had it there the whole time. So if you look here, there is that cubic look, and we need to find this maximum here, which is 3,108. Okay, so 3 is our x value. That's that x we were trying to find. 108 is just our maximum product. Okay, that was our equals, right? So we know 3, if 3 is x, right, we can then plug back in, and we know that our y value is 6. And that solves that one. So the next one here, we're making a solution, right? So we have 200 milliliters of 5% solution. Okay, so we take that, and we have a 3% solution to use, and we have a 10% solution to use. Okay, so we'll name the 3% X, we'll name the 10% Y. We know that when we add those two solutions together, it has to equal 200 milliliters. Okay, and then what we do is we put our percentages in this. So we have 0.03 of X plus 0.1 of Y, and it must equal 0.05 of our 200 milliliters of solution. Okay, and then what we would do is we're solving a system. So again, most of us would do that by substitution, right? So we would say y equals 200 minus x. We would plug in. So 0.03x plus 0.1 times 200 minus x equals and I'm going to go ahead and do this, right? Because I'm going to go ahead and say that's 10. Okay, so I have 0.03x plus 20 minus 0.1x. Okay, I'm going to add like terms. So this is a negative 0.07x. If I subtract 20, it's going to equal a negative 10. And then I'm going to divide. And I get 142.857 milliliters of the 3% solution. And if I subtract that from 200 to get my Y solution, I should get 57.1429 roundabouts. Okay? Or we could just go ahead and make that 3 if that'll make it easier. 1. Okay. All right. The next one here is 66. We have a widget company. We have 800 widgets selling for $7 each. Okay, and they want to know if we increase the price 50 cents per week, right? Ever how many times we do that, we will lose 25 widget sales per time we do that. Well, if we're trying to find profit here or maximizing our sales, how would we get our price? We would multiply these. So let's just multiply these together. So we have 800 minus 25x times 7 plus 0.5x, and we get that profit, right? So now, once we have that, right, we want to find our maximum again, okay, our max. Well, if you think about this, you should know that this is going to make a negative quadratic, right? So that would be like this, and we would have a maximum, right? So what we can do right now in pre-cal is we can graph this, and we can find our maximum, okay? So again, if we put this in, so let's go 800 minus 25x times 7 plus 0.5x, and we graph this, we can see our parabola, right? And our maximum is going to be way up here somewhere. There we go. So our maximum is 9 and 6,612.50 or 50 cents. So 9 is our number of times we increase the price. So if 9 times we increased it 50 cents, we actually increased it $4.50 from our original $7. So our actual price of our widget is $11.50. Now you may be saying, Coach, but we lost widget sales. Yes, but we're still maximizing our sales because we still have enough people buying it at a more expensive price. Okay? Moving on here. Okay, so now we're talking about direct variation. And so there's some math notes here that talks about what direct variation is, and this y equals kx, that there's always this constant of variation. And so that's what we're doing on the next one here. And so I'll try to solve these rather quickly here. So we have circuits. Again, if you want to talk to me about electricity and circuits, we can have that conversation. I talked a little bit about it in class. But basically what we have is this direct variation. So we have our resistance in ohms. So we have 150 ohms. And it equals that K constant of variation times our length of our wire, so 2.4 meters, over our diameter, or our twice our radius squared, which is just our diameter squared, so 0.004 squared, right? And so in order to get our direct variation, or our constant of variation, we're just going to divide this over, right? So if you put that in your calculator and you do 150, right, divided by, and you do this constant of variation, right? You get a constant of variation of 0.001. Well, now we can use that to then solve the next part of this, right? So what is the diameter? We're trying to find D. So we have 90 ohms. We have a resistance of 90 ohms. We have a 0.001 constant of variation. We have a 1.2 meter wire, and we're trying to find this diameter squared. Okay, so well, 1.2, let's go ahead and do this, right? This 1.2 times 0.001, right? And so I'm basically multiplying D squared over, and then I'm going to go ahead and multiply this together here. Okay, so this is 0.0012. This is 90D squared. So I'm going to divide by 90, and then I'm going to take the square root. So this is 0.000013. Then I'm going to square root this, right? And I should get a diameter of 0.003. Okay. And then the last one's here, this law of gravitational. So your natural law of gravitational between two objects, right, is 1. And we have this constant of variation. We have mass 1 and mass 2 divided by, divided by the square of the distance between them. So again, we're squaring distance. Okay, and so what happens here is they're talking about percentage increases and decreases. So we're not really putting in numbers, we're putting percentages in. So if we're trying to find this change in this deal here. So if one mass changes, sorry for that.
Ellie Jones, please come to the office for dismissal. Ellie Jones. And the announcement is students who took the ACT can pick up their score reports in student services. Thank you.
So we have an increase of 20%. So instead of 100, it's 120%, so 1.2. And then we have a decrease in 20% for mass 2, that's 0.8, over our distance reduced by 0.25, so that's 0.75 of our distance squared. Now that 0.75 squared too, so we just want to find the percentage change here. So what we can do is we can actually just take these numbers and do the math there, and we will actually find percentage change. So what we're going to do is go 1.2 times 0.8, and we're going to divide that by 0.75 squared, right? And we should get a value of 1.70, right? Or 71 if you, let's just round to 71. Okay, and what's our percent change? It increased by 71%. Okay, so that's solving word problems, and I didn't dig in or pry there. I just basically showed you how to solve the ones they had. But this is a bunch of different examples of word problems and how to do those. So hopefully if you have anyone close to that, you would be able to at least know where to start.